Welcome to the Explainer. So, if you're a homeowner trying to figure out exactly why your massive home upgrades just aren't delivering the savings you were promised, well, you are definitely in the right place. Today, we're skipping the marketing fluff. Instead, we're going to dive straight into the hard data from real 2025 energy bills to uncover exactly why your heat pump investment might be severely underperforming.
I mean, it's an incredibly frustrating scenario, right? You dropped a massive amount of money upgrading your home. Your contractor sat right there at your kitchen table promising lower monthly bills, a greener home, ultimate comfort, the whole shebang. And then that first winter bill arrives in the mail, and it is a massive shock. In a lot of cases, it was actually higher than the old fossil fuel bill.
Okay, let's really dive into this. If you're feeling completely defeated by that high bill right now, I want to validate your feelings. You are not imagining it, and you are absolutely not alone. Look at this exact sentiment echoing all across the internet. Search engines and forums like Reddit are literally flooded with these exact complaints from average homeowners right now in 2025. These are valid, recent, and incredibly widespread problems. You're not crazy.
Just to anchor the stakes here, we're talking about an average upfront cost of roughly 10,000 euros. That is a massive investment. But I want to confidently state something right out of the gate. The high bills you're seeing, they're almost certainly not the machine's fault. Modern heat pumps are actually incredible pieces of engineering. The failure lies entirely in how the system was sold to you, how it was sized for your specific house, and how it was actually installed on your wall.
So, here is our roadmap for this explainer. We're going to break down 5 specific industry-hidden traps. 1. The sizing trap. 2. The flow temperature mistake. 3. The auxiliary heat trap. 4. Time of use peak pricing. And 5. The bad installation factor. Let's get right into it.
Mistake number 1. The sizing trap, or the bigger is better myth.
Now take a look at this staggering number, 54%. Approximately 54% of heat pumps installed today are completely oversized for the homes they're actually heating. Why? Well, because installers are often just guessing. They look at your old, inefficient gas boiler, see that it was an 18 kilowatt unit, and lazily copy that number, slapping an 18 kilowatt heat pump right onto your quote. But a heat pump is not a boiler. It's a precision machine meant to run continuously at low power, not just blast heat in giant bursts. When you oversize a heat pump, it gets your home to the target temperature way too fast, and then it shuts off. A few minutes later, it turns right back on. This is what we call short cycling. Think of it like driving a car in really heavy stop-start traffic. You're constantly hitting the gas, then the brakes over and over. It burns massive amounts of electricity and completely ruins your efficiency. The absolute non-negotiable fix here is to demand what's called a manual J load calculation before you sign any contract. It's a proper engineering assessment of your home's actual heat loss. Seriously, if they won't do it, just walk away.
Mistake number 2. The flow temperature mistake. The efficiency collapse.
We really have to contrast how we used to heat homes with how we do it now. See, your old gas boiler was basically a brute force machine. It heated the water flowing to your radiators to a scorching 60 to 70 degrees Celsius. When a heat pump replaces that boiler, a lot of contractors just leave the flow temperature cranked way up to 55 degrees or higher, just because that's what your old radiators are used to. But heat pumps require low temperature precision, ideally somewhere between 35 and 45 degrees. Forcing them to run hotter literally destroys their efficiency.
Let's actually look at the math behind that efficiency collapse. We measure heat pump efficiency using COP, or coefficient of performance. At a gentle 45 degrees, you get a COP of 3 to 4. That means for every 1 unit of electricity you buy, you get 3 to 4 units of heat back. It's magic. But look what happens when you push that flow temperature up to 60 degrees. Your COP drops to 1.5 or even less. You are paying the exact same high electricity price, but you're getting less than half the heat output. The fix? Lower your flow temperature to 45 degrees. And if your rooms feel cold, the answer isn't to turn up the heat. It's to upsize your radiators so they can emit more warmth at those lower temperatures.
Mistake number 3. The auxiliary heat trap. The sub-zero problem.
This one is wild. The crucial point here is this shocking contrast taken directly from a real 2025 energy bill. On a normal winter day, this homeowner was using a totally reasonable 30 kilowatt hours of electricity. But during a deep freeze, their usage skyrocketed to 130 kilowatt hours in a single day. That is over 4 times their normal consumption. So why on earth did that happen? Well, it happened because of auxiliary heat. When standard heat pumps hit their extreme cold limit, they kind of panic. To keep your house warm, they switch on an internal electric resistance heater. It's basically a giant electric space heater inside the unit. And when this happens, your amazing high-tech COP efficiency instantly plummets to exactly 1.0. You are paying full top-dollar price for basic electric heat. To protect yourself, empower yourself when buying. Explicitly specify a cold climate unit rated to handle -25 degrees Celsius, and ask the installer, point blank, what is the published COP rating at -15 degrees? If they don't know the answer, do not buy from them.
Mistake number 4. Time of use peak pricing. The 6 p.m. to 9 p.m. danger zone.
Consider the massive disparity on a dynamic tariff. Your electricity price changes based on grid demand, right? You might pay just 7 cents per kilowatt hour during off-peak times, but during peak hours, that can spike to 95 cents. That is an unbelievable 13-to-1 price difference on the exact same grid on the exact same day. And when is the peak? Usually right between 6 p.m. and 9 p.m. Exactly when everyone comes home, turns up the thermostat, and makes the heat pump work its absolute hardest. You are quite literally paying the maximum possible price for every single unit of heat.
So, the fix here is highly strategic, and it involves a smart thermostat. You need to start thinking of your home's physical structure, its walls, floors, and furniture, as a giant thermal battery. The strategy is to run the heat pump hard during those super cheap off-peak overnight hours, storing up heat in the thermal mass of your house. Then, when that expensive 6 p.m. to 9 p.m. danger zone hits, you just let the house comfortably coast. The heat pump barely even runs, you stay completely warm, and you totally dodge those massive price spikes. It's a real game changer.
Finally, mistake number 5. The bad installation factor. The industry's hidden secret.
Let's confront the elephant in the room that the heating industry absolutely does not want to talk about. Plain old human error on installation day. Up to 30% of a heat pump's additional energy consumption is wasted, not because the machine is defective, but because it was installed incorrectly. If a contractor connects a state-of-the-art heat pump to old pipework or ductwork that simply cannot handle the required flow rates, the system chokes. It'll run nonstop, burning electricity 24/7, and still fail to actually reach the temperature you set on the thermostat.
Look, if your home isn't reaching its set point and the system is running continuously, you are very likely the victim of a bad install. The fix here is all about prevention. You cannot just hire a general gas plumber who watched a quick weekend certification video. You need strict vetting. Hire a certified heat pump specialist. Look for credentials like MCS certification in the UK or whatever your local equivalent is, and demand references from previous heat pump installations.
So, let's bring this all together. The hardware absolutely works. When sized, optimized, and installed correctly, heat pumps will provide real comfort and significantly lower your emissions. To guarantee those lower bills, remember these 5 actionable fixes. Demand that manual J calculation. Drop your flow temperature down to that 35 to 45 degree target range. Insist on a cold climate rating if you live in a freezing zone. Use a smart thermostat to preheat during cheap off-peak hours. And finally, properly vet and hire a true certified specialist.
If you found this explainer helpful, make sure to catch our next one right here on YouTube, where we tackle the ultimate homeowner dilemma: insulation versus solar versus heat pumps. What should you actually do first? Getting the order of these home upgrades wrong will absolutely cost you thousands of wasted dollars. Also, if you're looking at your own system right now and wondering if you've fallen into one of these traps, drop your questions in the comments below. We read every single one of them.
I want to leave you with this final, somewhat provocative thought. The technology inside your heat pump, it is absolutely ready for the future of green energy. But was your installer? Armed with this knowledge, you now have the power to take full control of your heating bills, thoroughly vet your contractors, and make sure your home upgrade actually does what it promised. Keep learning, stay focused, and I'll catch you in the next explainer.